Same reference image, 5 different generation modes, and the result can go from a fast draft in a few seconds to a high-detail 3D asset with millions of polygons. Today on Eisen Tools, I'm testing Hyper3D Rodin Gen-2.5, and I want to see how much the generation setting actually changes the final model. But this time, instead of a sci-fi creature, I'm testing it on something a lot of you actually asked about: real product references and a human character reference. For this test, I'm using 3 very different materials. First, a leather jacket, smooth surface, sharp seams, metal zipper hardware, and reflective sheen. Second, a knit fleece jacket, soft heather texture, matte finish, ribbed cuffs, and collar. Third, a close-up human portrait, skin texture, pores, and facial detail to see how Rodin handles a character or avatar reference instead of a product. Before showing the workflow, here's the final result. On one side, we have the fast version created for quick exploration. On the other side, we have the extreme high version with much more geometry detail, cleaner surface definition, and a stronger result for a close-up hero asset. The interesting part is that Rodin Gen 2.5 is not trying to give every project the same amount of processing. You can decide whether you need something fast for ideas, something balanced for a real product mockup, or something much more detailed for a close-up asset, whether that's a garment or a face.
Yo, what's up guys? Welcome back to Eisen Tools. Lately, I keep hearing about
Hyper3D.
so I figured why not check it out? So today we'll see what it can actually do and whether it's worth the attention that it's getting. So don't forget to like the video, subscribe if you haven't, and tell me in the comments which AI tools should be next on the list.
I start by uploading the leather jacket reference into Hyper3D Rodin. Then I open the generation panel where I can choose between 5 modes: extreme low, low, medium, high, and extreme high. The fastest mode is designed for quick experiments. For a simple product prop or an early e-commerce concept, Rodin can generate a model in around 4 seconds. That's useful when you're not looking for the final asset yet, you're trying to check silhouette, compare angles, or generate several options before committing to one. So first, I select extreme low and generate a batch of models in parallel. Instead of waiting for one result at a time, I can increase the amount and create multiple versions from the same input. In a few seconds, I have a group of fast 3D drafts that I can rotate, compare, and use to decide which direction is worth developing. Now I move to medium mode. This is where the jacket starts to feel more balanced. The model has more structure, cleaner proportions, and better surface definition, while still being fast enough for everyday product previews, e-commerce mockups, or quick catalog assets. Then I go all the way to extreme high. This setting takes longer because Rodin is putting more effort into the model. The process can run up to around 80 seconds, but this is where the high-frequency detail becomes much more visible. For this version, I choose the faithful option because I want the model to stay close to my reference image. I also select micro mode so the result focuses more on small surface details instead of keeping everything overly smooth. One thing worth highlighting here is the 10 million polygon option. This mode is designed for situations where preserving fine geometry matters much more than generation speed. Instead of simplifying small surface features, Rodin keeps significantly more geometric information, making details like stitching, folds, seams, and hardware much cleaner when viewed up close. You can switch between 2 million and 10 million polygon counts here to boost output quality. I'll stick with 2 million for now since I'm going to enable 12K mode later to showcase fine generated details. Hyper3D Rodin Gen 2.5 can generate assets at a much higher geometry level, including models with more than 10 million polygons in its high-detail workflow. That's not something every project needs, but for close-up product shots, apparel catalogs, and detailed e-commerce visuals, it gives you much more to work with before you even open another 3D tool. And this is the first major difference you can see on screen. The extreme low version is useful for speed. The medium version is a good middle ground. But the extreme high version gives me much more information in the zipper hardware, the stitching lines, the collar folds, and the way light plays across the leather sheen. Now I want to test how Rodin handles a completely different material, soft, textured fabric instead of smooth leather. So for this second test, I use the heather gray fleece jacket reference, a knit texture with a matte finish, ribbed trims, and much softer surface variation than the leather piece. Inside Rodin, I enable the texture workflow and use the delete option to help reduce lighting and shadow information from the original image before the texture is generated. Then I rotate the finished model all the way around. The goal here isn't just to see whether the front looks good. I want to inspect the side, the back, the pockets, the ribbed collar, and the areas that are usually difficult for image to 3D tools, especially with soft, low contrast textures like knit fabric. Rodin Gen-2.5 uses a 3D native texture workflow, and the high detail tier supports textures up to 12K. That is world's first 12K. The important result is that the texture is designed to wrap around the asset instead of treating unseen areas like an afterthought. You can see that the heather knit pattern stays consistent as I rotate the model, the seams hold their shape, and the fabric doesn't flatten out or lose its texture on the back or sleeves like a lot of image to 3D tools tend to do with soft materials. For the last test, I want to push Rodin outside of product work entirely and see how it handles a human portrait reference, something closer to a character or avatar use case. I upload the close-up portrait and run it through the same extreme high, faithful micro workflow. This is a harder test than either jacket. Skin isn't a flat material. It has pores, subtle color variation, and soft shading that shifts constantly with the light. I want to see whether Rodin can hold onto that realism instead of turning the face into a smooth, plastic-looking surface. Here I'm switching to the 10 million polygon geometry option. This setting prioritizes geometric detail over generation speed, allowing Rodin to preserve much finer surface information. It's especially useful for close-up assets where details like stitching, folds, facial features, or small surface transitions need to remain well-defined instead of being simplified. But I'll select 2M for geometry, and I'm going to enable 12K mode on material section. Before looking at the result, it's worth highlighting the 12K texture workflow. Higher texture resolution allows much finer surface information to be preserved, especially on materials with subtle detail like human skin. Instead of flattening those details, it helps retain variations in skin tone, pores, and other small facial features that become much more noticeable in close-up views. As I rotate the model, you can see that the facial texture remains consistent from different angles. Areas like the cheeks, forehead, and jawline keep their subtle skin variation instead of becoming overly smooth or losing definition. For character creation, digital avatars, or cinematic close-up renders, having higher resolution textures gives you a much stronger starting point before moving into Blender or another 3D application. Now let's take this beyond the preview window. I export the selected models and bring them directly into Blender. This is the part that matters most to me, because a great-looking preview isn't enough if the asset becomes difficult to use once it enters a real workflow. Inside Blender, I can rotate each model, inspect it under different lighting, and switch to wireframe view. What stands out is how quickly I can move from a single reference image to a usable 3D asset, making the early stages of product visualization and asset creation much faster. For rapid product prototyping, e-commerce previews, character concepting, or early production assets, this can remove a huge amount of time from the first stage of the process. Back inside Rodin, I also want to show one more practical feature. Let's say I like the overall jacket model, but one section needs changing, maybe the collar or a pocket. Instead of regenerating the whole asset, I can use bang to parts to split the model into editable sections. For example, I can isolate the collar, a sleeve, or a specific hardware detail. Then I can refine just that part without starting from zero. There's also Smart Low Poly mode, which can help create a cleaner, lighter version of a detailed asset when I need something more practical for a real-time product viewer or a faster scene. But for rapid product prototyping, e-commerce previews, character concepting, or early production assets, this can remove a huge amount of time from the first stage of the process. This is why Hyper3D Rodin Gen-2.5 feels more useful than a simple image to 3D generator. You can start with almost any kind of reference, a leather product, a fabric product, or a human portrait. Choose the level of effort you need, generate multiple versions in parallel, inspect the geometry and textures, refine individual parts, optimize the model, and export it into a real 3D workflow. For fast ideation, Extreme Low can get you a usable starting point in seconds. For more detailed assets, the higher modes give you more geometry, stronger texture fidelity, and more room to continue refining the model in your own pipeline, whether that's a product catalog or a character project. You can register on the Hyper3D website to try Rodin Gen 2.5. Use my exclusive code, YourCode, for an additional 14-day free trial. Let me know in the comments what you'd create first with it. A product mockup, a fashion asset, a character or avatar, or something for 3D printing.